Okay, hi, welcome to Research Practicum. We're going to take a quick look here at the chi-square test, and this is going to be a simplified version of it. We won't be covering all the details, but just enough to get you started. We're using the basic hypothesis testing procedure here. So first we will define the null and alternative hypotheses, then we'll design a study to gather data, test it, and then calculate its probability. So a null hypothesis within a chi-square is often that there's no difference, but it's between the number or percentage of people in a group. In other words, chi-square always involves counting. That's something that's very important to remember. What you're doing in chi-square is counting the number of people who fit a category and asking whether or not it's more or less than you'd expect by chance. Most of the other statistics we're going to be using involve calculating means. In this case, we're not calculating means, we're counting the number of people. And that means that we'll use a chi-square procedure to evaluate this. So if we're looking at designing a study to gather the data, we need to gather data that's categorical. In other words, data where the codes represent the groups people fall in. For example, we're going to take a look at a study in a minute of musicians. So do they play guitar or do they play piano? Which category of instrument do they play? Were they trained formally with lessons or informally by picking it up? So they're in either the formal or informal training category. And so what we're going to do is look at, is there an association between the type of training that you get and the type of instrument you play? Okay, we'll get to that in just a moment. As I said, because we're counting, we're not computing the mean number of pianos or the mean guitar strings or anything like that. We're just counting the number of people who play guitar, the number of people who play piano, the number of people who were trained formally, the number with informal training, and then combining those categories. So we're counting. That's a chi-square statistic. So we're going to be computing chi-square. Chi-square does have other uses. We can look at those elsewhere. But right now we're just doing the chi-square test of association. In this case, we're going to be looking at the association between two categorical variables. And then the chi-square will produce a probability based on the sample size that we have, and then we can decide whether or not we've got enough evidence that there's a relationship between training and musical instrument, or whether there's not a relationship. I'll explain that in just a minute. So here's our example research question. So you might even fall into a category yourself. Maybe you've picked up a musical instrument or know someone who has. Sometimes you learn them through formal classes, lessons, progress through levels. Other times you find musicians who've just learned it themselves. They've taught themselves, or they've learned it by jamming with other musicians, or they just ask experienced people to show them a thing or two, and then they just pick it up and incorporate it into their own playing. And what you may have noticed if you've been around some musicians is that sometimes it seems that guitar players are quite informal about the whole thing, whereas piano players tend to be more structured and formal. It's almost like guitar players want to improvise and piano players want to get it right. So I actually had a student who came to me with that proposition. That was what he wanted to do his honors thesis on. So it turned out he was an informally trained musician. His brother had formal training, and they were talking about how their motivation was different. So in this particular category, we're going to look at, does the type of instrument that you play, either guitar or piano, is that related to the type of training that you have? So is there a preference for piano players to have formal training, guitar players to have informal training? So we're going to count the number of guitar players and piano players, the number with formal training and informal training, and see how the percentages balance out. So here are three possible patterns. On the left, you see a pattern where there's basically no relationship. I could have made those numbers dead even, but real data never turns out that way. So in this case, we've got 49 piano players with formal training, 51 with informal. It's roughly 50-50. Guitar players, about half of them have formal training, around half of them have informal. The actual numbers are 51 to 49, so it's roughly the same number of guitar players with formal and informal training. In the top row, piano players have informal and formal training in roughly the same numbers. So there's no relationship in that first data set between training and type of instrument. In the middle data set, we see more of a relationship here. In this case, we've got 55 piano players with formal training and only 45 with informal. The reverse happens for guitar players. 45 with formal and 55 with informal. There seems to be a separation happening here. There seems to be a relationship coming along. So in this case, more often piano players have formal training, more often guitar players have informal training. So there looks like there might be a relationship there. There's a small relationship. In the third data set on the right here, there's clearly a relationship. In this case, 85% of the piano players were formally trained. Only 15% picked it up on their own. Whereas with the guitar players, 2/3 had informal training and 1/3 had formal training. So in that last category on the right-hand side, very clearly training depends on the type of instrument. If you've got a piano, you're probably formally trained. If you're playing guitar, it's a 2-to-1 probability that you've got a informal training background, right? Because 66% is double 33%. So if you look at these different patterns, we can see that the two variables, formal, informal training type, piano and guitar instrument type. So training and instrument, how are they related? Well, on the left, they're not related. The percentages are all very similar. In the middle, there seems to be a relationship. And on the right, there's very clearly a categorical difference. The piano players get one type of training. The guitar players more often get another. It's not perfect, but there's definitely a pattern there. With chi-square, the output will include raw numbers, like the counts we just saw, or percentages if you request them, whichever is helpful for you interpreting the larger data set. And there are other ways to use chi-square, but this is the chi-square test of association. Now we're going to try an example here. In this case, if you look at the data set that we have on the screen, you've got two groups, Group A and Group B. And I've got all the Group A's here and all the ones here in Group A and all the twos down here. And here I just go 1, 2, 1, 2, 1, 2, 1, 2. See? Okay. In this case, because I went 1, 2, 1, 2, 1, 2, if we look at the Group A's who scored 1, half of them got a 1 and half of them got a 2 over here in variable B. Down below among the twos, same pattern, no relationship. What we're going to do in class is we're going to start trading the ones for twos up here only when Group A equals 1. We're going to convert some of these ones into twos and see what happens. The more ones here become twos. In other words, Group A, if your score is 1, you're likely to get a score of 2 over here. If that's the case, we're starting to create that pattern again. We're starting to create an association. All right, so as it stands here, there's no association between the ones here and the ones here. So Group A is just as likely to have 1 or 2, and Group B is 1 or 2. There's no pattern to be found, but we're going to start creating a pattern and see what it looks like. So initially the data set looked like 1s and 2s, but now we've got all kinds of 2s up here. In fact, we've turned everything into a 2 except this one lonely 1 here. And then here we still have the patterns of 1 and 2s at the bottom. So in Group B, we've got a mix of 1 and 2s if Group A category was 2. But if Group A category was 1, it's almost always a 2. So here we have the count. We can see if Group A category is 1, Group B category, only one of them had a 1. 9 out of 10 have a 2. Whereas if the Group A category down here was a 2, 5 had 1 and 5 had 2. Right? So half had a 1, half had a 2. Here, 90% have a 2. This definitely looks like a pattern. When we run the chi-square test, we get these results. Look at this, 0.051. That's not significant. It's really close to 0.05, but it didn't get less than 0.05, so it's not a significant pattern. But I want to point out to something down here. The SPSS gives you a warning. JASP does not give you this warning. In this case, 2 cells have expected count less than 5. I want you to remember that. I'm not going to deal with it now. We're going to look at it later. Now, what I did here was I simply doubled or duplicated the sample. Just doubled it. So now I have a much bigger sample size. I've got 40 instead of 20. And now with exactly the same pattern, all these numbers just doubled, suddenly the chi-square is significant. Sample size matters. The larger the sample, the more likely you are to have a significant difference, even if there is a relationship, or you're more likely to find a relationship if you have a larger sample. Okay, so that's how to do a chi-square. So this PowerPoint will be available to you, this video is available to you, and hopefully you'll be able to try a few of these on your own in class. Thank you.